Good morning, dear students. In last video, we talked about Arrhenius theory and Debye-Huckel theory, and today we are going to talk about two effects which are seen in concentrated solutions related to conductivity process. That is why you can say that if the question is asked why there is a decrease in conductivity of concentrated solution, then for these two effects are responsible. The first is relaxation effect and the second is electrophoretic effect. Now first we will talk about relaxation effect. Now when we say a concentrated solution or a solution is there, then naturally there will be presence of ions, positive and negative ions, and every time it is told that if there is a positive ion, then surrounding it there will be a atmosphere of negative ions, means the positive ions will be surrounded by negative ions, and negative ions will be, if there is the central negative ion, then it will be surrounded by positive ions. So naturally this will become the ionic atmosphere that we have seen in the previous classes. Now this effect is giving rise to some new concepts. Now whenever we will talk about the EMF, now if a particular potential is applied in that particular solution in which these ionic spheres are there or ionic atmospheres are there, positive and negative atmospheres, number of atmospheres will be there. So in that, if we applying the EMF, suppose it is the positive atmosphere, that means the positive ion is at the center and the negative ions are surrounding it, and the EMF is applied. So naturally positive and negative potential will be there. Now if as soon as the potential is applied, so this positive charge or positive ions will be attracted towards the negative potential, and in this condition, as it is surmounted by or surrounded by many number of negative ions, so these negative ions are retarding its speed to get attracted towards this negative terminal. Now what this positive charge will do or positive ion will do, it will move towards the negative terminal or opposite terminal, and in this process, as it is moving towards the negative terminal, all the positive all the positive all the remaining ions which are present here in its surrounding will lag behind, मीन्स वो पीछे छूट जाएंगे, और ये जो पॉजिटिव आयन है जो सेंटर में है वो टर्मिनल की तरफ अट्रैक्ट हो जाएगा, अपोजिट टर्मिनल की तरफ अट्रैक्ट हो जाएगा. अब जैसे ये जो आयंस है जो लैग बिहाइंड हो गए, मीन्स विच आर लेफ्ट बिहाइंड and the ion is moved forward, so that ions will be surrounded by another positive ion. So in this phenomena there is a time span in which this new sphere is forming here around a new positive ion there. Actually the ions are already present there and this process is continuous. So again this new atmosphere is surmounted here in the neighborhood of that old positive ion which was attracted towards the negative terminal. Now this time duration in which this atmosphere is or new atmosphere is forming, ionic atmosphere is forming, that is called as relaxation time, and this effect is called as relaxation effect. Now due to this applied EMF, the ionic atmosphere is always moving in opposite direction to the as compared to the central ion. Similarly the central ion which is present here, so central ion will be having opposite direction and its ionic atmosphere which is surrounding it is having opposite direction. So naturally the central ion's movement is retarded or obstacled by the surrounding ions. So naturally this movement of ions is slowed down and this is called as asymmetric effect. When EMF is not applied, then it is symmetric. All the ions are surrounding the central ion and this is symmetric effect. When the EMF is applied, this type of unsymmetry can be seen. So that is called as unsymmetric effect. So that is because of the lack of symmetry in the ionic atmosphere. So that is what you have to explain in relaxation effect. Then comes electrophoretic effect. Now when we talk about electrophoretic effect, when we are saying there is a solution, so naturally there are a number of solvent molecules are there. So in that solvent molecules are forming the positive and negative ions, and naturally the ionic sphere is there. Now this ionic the solvent molecules which are attached to this ionic sphere, they always move in the opposite direction to the central metal ion, and naturally they will stop or obstacle or retard the movement of और मोशन ऑफ सेंट्रल मेटल आयन. वो सेंट्रल मेटल आयन की जो स्पीड है या उसकी मोशन है या उसकी मूवमेंट है उसको कम करता है या रोकने की कोशिश करता है. सो रिटार्ड कर रहा है. जो नेचुरल उसकी स्पीड होनी चाहिए वो ना होते हुए इन अपोजिट चार्ज्ड आयंस की वजह से उसकी मूवमेंट जो हो रही है वो स्लो डाउन हो रही है. सो बोथ this is which is happening here, that is called as electrophoretic effect. So electrophoretic effect is because of the solvent molecule, and relaxation effect is because of the ionic atmosphere. So that you have to keep in mind, and both of these effects are responsible for decrease in the velocity of ions. Hence this decrease will cause a decrease in the conductivity of the solution. Now if you increase the dilution, so naturally the equivalent conductivity will increase. So hence, so at infinite dilution, that is relaxation effect and electrophoretic effect will disappear at infinite dilution. But in other dilutions, this effect will have a direct relation with root of concentration, square root of concentration. Directly proportional means they will have a direct effect on the concentration of the solution, or they are depending upon the square root of concentration of that particular solution. So that is what about the two effects that are seen here. The next is Onsagar equation. Now Onsagar equation में आपको याद रखना है कि ये आपको जो फॉर्मूला दिया है वो आपको अच्छे से याद कर लेना है. इस ऑनसागर इक्वेशन में एक्चुअली इसका दूसरा नाम है डिबे-हकल ऑनसागर. जो हमने डिबे-हकल थियरी देखा था उसका ही एक्सपांशन है जिसमें ऑनसागर ने उसका कंट्रीब्यूशन किया है. एंड दे हैव टॉक्ड अबाउट सिमेट्रिक और रिलैक्सेशन इफेक्ट एंड इलेक्ट्रोफोरेटिक इफेक्ट को एक्सप्लेन करने के लिए ये डेरिवेशन या इक्वेशन डिराइव किया गया है, जिसमें इक्विवेलेंट कंडक्टेंस इज इक्वल्स टू इक्विवेलेंस कंडक्टेंस एट इन्फिनिटी माइनस दिस फर्स्ट वैल्यू प्लस सेकेंड वैल्यू into lambda infinity, and it is all these values is multiplied by square root of concentration. Now in that we are taking the first value as a, and this second value which is taken as a constant is as a b. Here you can see it in the detail. Now when we talk about the meaning of each of the terms, especially this d is dielectric constant, neta is constant of viscosity, T is the temperature at which this concentration of solution is measured, C is the concentration of solution in gram equivalent per liter, and these are the terms which are involved in the process. So these values you have to keep in mind. Now when we solve this each of the constant terms here, you will get this value. So this equation will again have a new form at 25 degrees Celsius. After solving it, we are getting this first value a as this and b as this. So these two a and b are actually representing the electrophoretic effect and relaxation effect or asymmetric effect. So that values are involved here, that effects are involved here. Now again a graph is drawn here for conductivity versus root of concentration. Like equivalent conductivity, here you can see for some of the solutions here, univalent solutions, and silver nitrate is also there, NaCl is there, and the graph is plotted here. So that is what about all the topics which are in this chapter. That is the end of this unit 1. That is electrochemistry 1. Some questions are also there so that you can see in the PDF file. I hope up to this you have understood. You have to remember this formulae which are very important here. I will just recap whatever is very important here. So this formulae, then the terms involved in their meanings, that also you have to keep in mind. Again, the next thing, these are the effects, that is electrophoretic, relaxation effect, or a relaxation effect is also called as asymmetric effect, one and the same. So that also you have to keep in mind. Then Debye-Huckel theory is there. Then degree of ionization or dissociation, its formula is there, that also you have to keep in mind. Then comes the Arrhenius theory, its limitations are there, that also you have to go through. Arrhenius theory, then conductometric titrations, that all categories I have told you, that also you have to keep in mind. Advantages, then conductometric titration, the definitions, all this you have to keep in mind. I hope you will keep on going in your studies, do hard work and score good marks. Thank you and have a nice day.